This is the post-test study guide for part 2 for Algebra 2, semester 1. Okay, so we left off on number 11 last time. So let's look at this question. It says, is x plus 3 a factor of this polynomial? If it is, write p of x as a product of the two factors. So you have a choice here. You can either do long division or you can use synthetic division. I'm going to show you both ways, and again, you can choose which one you prefer. So remember, if you're going to do long division, we're going to write the x plus 3 in the front, and then we're going to write each of our things, and always check to make sure you're not missing any of the exponents. We got x to the third, we have our x squared, our x, and our constant, so we're not missing any of them, so we don't have to put in any zeros. Okay, so then we look at our first term only, and we say, what do I need to multiply x by to get x to the third? And we need to multiply it by x squared. So that gives me, when I multiply x to the third, then x squared times 3 is a positive 3x squared. Put that in parentheses and subtract it. Okay, remember that changes the signs on both of those, so that gives you a negative x cubed, which then gives you 0, so those just cancel out. Then this makes a negative 3x squared. If you add that to the 4x squared, you just get a positive x squared, and then bring down your next term, so plus 16x. Okay, so then again, x can go into x squared, we need 1x. So x times x is x squared, x times 3 is 3x, and then again, you're going to put that in parentheses and subtract. Okay, so that cancels out the x squareds. That makes that a negative 3x. If you add that to the 16x, you're going to get the 13x there. And then we're going to bring down the 39. Okay, then we're saying x goes into 13x 13 times. So 13 times x is 13x. 13 times 3 is positive 39. Put that in parentheses and subtract. So that's going to subtract both of those, so we have a remainder of 0. So is it a factor? Well, if we get a remainder of 0, then the answer is yes. And then when it wants us to write it as the product of two factors, okay, this is where you're going to take what you were dividing by, so the x plus 3, and then multiplying it by that quotient that you got, the x squared plus x plus 13. Okay, so that's what they're looking for this answer. So if it goes in and you get a remainder of 0 at the end, right here, then you know it is a factor. And so then you write the two pieces, the dividend and the quotient, as a multiplication. Okay, so that's what it means as a product of two factors. Okay, we already know what the answer is going to be, but if you don't like long division, let's go back through and let's show it with our synthetic division. So you can just review what that looks like if you prefer the synthetic. Okay, so with synthetic division, okay, remember you're going to take what you're dividing by, the x plus 3, we set that equal to 0, and you solve for x. Remember that changes the sign to negative 3. So when we do our synthetic division, we're going to use negative 3, and then we're going to use the leading coefficients. Remember, if there's not a number there, it's going to be 1. So we're going to do 1, 4, 16, 39. If you had a minus sign in there, you would put that in front of the number, but ours were all plus. So remember, the first number comes straight down, and then you start to multiply. So negative 3 times 1 gives me a negative 3. Then we add that column. That gives me a positive 1. The negative 3 times 1 gives me a negative 3. Add that column. That gives you 13. And then negative 3 times 13 is a negative 39. Add that column, we get 0. Okay, so remember this last number is your remainder. So if you get a 0, then of course that's why we answered yes, it is a factor. Okay, and then you're going to take this piece, and remember you do 1 less x than you started with here. So when we go to put our numbers back in, you're going to do, if you have a 1 there, you can just write it as x squared plus x plus 13. So again, notice it's the same as what we got before. And then in the front, you go back to your original, the x plus 3. So just like we did the last time, that's how you would write it as a product of the two factors. Okay, so again, it should be the same exact answer as what we got when we did the long division. Okay, so you not only have to go through and find the quotient, but then you have to write it as two things being multiplied, okay, as your final answer. Okay, on number 12, we did a question similar to this on our quiz from the last unit. So it says, sketch a graph of the polynomial function. Use the graph to complete the statements below where values are rounded to the nearest tenth. Okay, so they're just talking about like these here. Okay, they rounded their values. Some of them have a little more than just 1 decimal place. Okay, but basically just plug that equation into the graphing calculator. So graph on calculator. Okay, and then when you graph it on the calculator, you can go through, and if it's helpful, make yourself a table of values. Basically, I'm just going to give you some points. And again, this is just by looking at the graph once you have it on the calculator. It has some zeros. Right here at -1 has a 0, at 0, and at +4. Okay, and then because it is an odd exponent with a positive in the front, remember that makes an S shape that starts down and ends up, and that's exactly what this one does. It starts down here and it goes up, and then it comes back down, and it kind of goes off to your graph here, and then it goes back up again and ends up. And again, you just need to make a sketch of the graph. Okay, and it may be that you're just choosing, because on these ones, since they're on the computer, they may just be where it's a multiple choice. So again, if you're just trying to figure out what graph this is, okay, you may just be looking at the graph on the graphing calculator, or it may be multiple choice where you're choosing the correct graph and then you're filling out these boxes. Okay, remember the 4 things that you're filling out are going to be positive, negative, increasing, decreasing. So let me just write those over here. You got increasing, decreasing, positive, and negative. And on this one, on the actual test, they'll just be drop-down boxes. Okay, so like on the test, when you come to these blanks, they should have like a little arrow to drop down the box, and you're just going to choose these. You only use each one time. Okay, so look at the intervals that they give you. So let's start with this one. So they're saying between -infinity to -1, and these are x values. These are not coordinates. These are intervals. So they're saying starting at -infinity and coming over to -1. Okay, so that means this part of the graph right here. And then also between 0 and 4. So between 0 and 4, they're talking about this part of the graph. Okay, both of those are underneath the x-axis, which makes them negative. Okay, so for that one, we would write negative, because that is where the graph is below the x-axis. Okay, let's look at the next interval. So between -1 and 0, so -1 and 0, we're looking at this part of the graph. And then between 4 and +infinity, they're talking about this part of the graph. Well, both of those are where it is above the x-axis. Remember, above the x-axis is our positive. Because remember, your x-axis is the dividing line between your positive and your negative. Okay, for the next one, if I'm looking between negative infinity and negative 0.4, well, negative 0.4 is about that height right there. So look at what's happening. As I come from this direction, look what's happening to the graph up to that point. Okay, that is where it is going up. Okay, and then also between 2.5 and positive infinity, and look, 2.5 is about right there is where it turned again, and it starts going up. Okay, so that is your increasing. Okay, if we look at that last one, it says between the negative 0.45 and 2.5. So that's between this max and that min. It is going down. So that is decreasing. So again, you're only going to use each one of those one time. And you have to get all 4 of them correct to get that one question correct on the test. So it's not hard if you just graph it on the graphing calculator and then look for each of those intervals and see what's happening with the graph at that between those points. And again, that's the x values that they're giving you. All right, let's look at 13. What are all the real and complex solutions of this equation? Okay, well, this is what we've been working on and what we just did in our last unit. So before we can solve, we got to move that 10 over here and combine it with our negative 18. So I'm going to minus 10 from both sides. Okay, so that gives me 0 over there. And then that's going to simplify to a negative 28. Okay, so I'm going to bring down all the rest of my numbers. So we got x cubed minus 4x squared plus 7x minus the 28. Okay, remember when we have 4 terms, we want to factor by grouping. So I'm going to group those together, and then I'm going to factor out what they have in common. So for the first set of parentheses, they have x squared in common, which leaves me with x minus 4. In the second set of parentheses, they have 7 in common. So that leaves me with x minus 4. So again, the parts in parentheses have to match. So then we're going to take what's in the front and write that as one set of parentheses. And then you only write one of the sets of parentheses that matched. Okay, not squared, just one. Okay, then to finish solving, we just set each of those equal to 0. Okay, the second one's pretty easy because we're just going to move the 4 over and it becomes positive. Okay, that already narrows it down to either the first one or the second one. So right away, I know it's not C or D. So then to solve the second one, if I bring that 7 over, that's going to become a negative 7. And so to finish solving, I'm going to do the square root of each side. Negative under square root gives us what? An I, and square root of 7 doesn't simplify. And remember, every time you do square root, you get the positive and the negative of that answer. So if we look up there to see which is the correct answer, it's going to be A. Okay, now remember, since these are multiple choice, you can just plug these in to see which makes it true if you want. Okay, so that is a shortcut. If you don't want to factor it all, this is going to always work out for you. But since they gave you options, you could plug this in on the graphing calculator with the I rad 7 in for everywhere there's an x and see if it equals 10. If it does, then that is your solution. Okay, where these other ones would not work. Okay, on number 14, this one states, given f of x equals 9x squared minus 6x plus 1 and g of x equals 3x minus 1, which of the following are expressions for f times g? Notice this is not the open circle. That is a multiplication sign. Okay, so basically you're just going to plug in your f. We're going to put it in parentheses, and then we're going to multiply it by our g. So let me write that out. So we're going to do 9x squared minus 6x plus 1, and we're going to multiply it by g, 3x minus 1. Okay, remember for this one, you're going to have to go through and multiply everything in this by everything in the second one. So 9x squared times 3x is going to give you 27x cubed. Okay, then for the next one, if I do my 9x squared times my minus 1, I get a negative 9x squared. So that just changed the sign. Okay, now I'm going to go through and multiply with my negative 6x times everything. So that's going to give me a negative 18x squared. And then negative 6x times a negative 1 cancels the negative and becomes positive 6x. And then I'm going to multiply the 1 by everything. So 1 times 3x gives you a positive 3x. And then 1 times a negative 1 is a minus 1. Then we're just going to go through and combine like terms. This is my only cube. Okay, we're going to add those x squareds together. So that's going to give me a negative 27x squared. And then we're going to combine these x's together. So 6 plus 3 gives me a 9x. And then the minus 1. Okay, you probably already noticed as soon as we did the first term right there that this is the only one with 27x cubed in it. Okay, there really is no shortcut for this one. You just have to write both of them down and go through and multiply it by every term in the second one. Okay, now this one also, notice how it says, select all that apply. Okay, so this one you're like, what? What else could it be? It didn't equal those others. Look at what we have right there. Okay, if you look at this piece in the very front, the 9x squared minus 6x plus 1, that is factorable. Okay, if you use your box method, okay, we could put our 9x squared and our 1 there. That gives you a 9x squared. Okay, and then we want to see what gives you the negative 6. Well, if they're going to be negative, then both of these have to be a negative. So what multiplies to 9 that adds to 6? Well, 3. And if we pull out what is in common, we can pull out a 3x. And this would also be 3x. And then this would be a negative 1. This would be a negative 1. So notice we would end up with 3x minus 1, 3x minus 1, and then that original one we started with, 3x minus 1, which is the same thing as D. So on this question, whatever you have in parentheses to the power is probably also the other solution. Okay, so this one you're going to have 2 that are correct. Okay, you can only have 1 out of these choices that could be true, but this one could also multiply out and give you what you have here. Okay, it's just that we're factoring this part and we get 3 of them, so this one is also correct. Okay, so again, watch for those ones that say select all that apply. So number 14 is going to be one of those ones, and there's going to be 2 correct answers. One of the ones with an equation, and probably the one that has the parentheses to a power. So there's just a hint on that one. Okay, so make sure you choose 2 of them on number 14. Okay, let's look at 15. So let f of x equal rad 4x plus 2, and let g of x equal 5x. Write an expression for f of g, what is the domain for f of g? Okay, so if we're doing f of g, remember we take g of x, so this one right here, and we plug it in for the x in the first one. So basically we're going to rewrite this as 4 times 5x plus 2, and then we're just going to go through and simplify it if possible. Okay, so for this one, if I simplify that, 4 times 5 is 20. Okay, neither one of those are perfect squares, so it's just going to stay like that. So that is our answer right here, 20x plus 2. So again, you just plug in g of x for the x that's in f and simplify it. Okay, so now it wants me to find the domain. Okay, so to find the domain, you can either go through and solve for x, or you could just graph this on the calculator. Okay, whenever you have a square root and you graph it on the calculator, remember square roots have this basic picture that looks something like that. Okay, but to figure out what that starting point is, and then it goes for whatever direction, it's either going to be, probably looks like it probably be positive infinity. It's going to go greater than that. If we want to see what this starting point is, we're going to solve it for our equation equaling 0. So if I take my 20x plus 2 and I set it equal to 0, well, to get rid of the square root, I'm going to square both sides. Okay, so then I'm left with the 20x plus 2. Of course, 0 squared is just 0. So then I'm going to subtract 2. That gives me a negative 2. And then I divide by 20. And that simplifies down to negative 1/10. Okay, so basically, I can do any number greater than the negative 1/10. So that's my x value for this point right there. So for my f sub g, we're going to have that your x can be greater than or equal to that point, the negative 1/10. So like if you graph it on the calculator, you get the basic shape of it, but you won't know exactly what that point is unless you take and you solve like this. So again, you're going to have something with a radical because this question is going to have a radical. So basically, whatever this is, plug it in for x, simplify it for part 1. Then for part 2, set it equal to 0. It's going to have the same basic shape because it's going to be a radical. And you're just looking for what that starting point is. And then it's going to be x is greater than or equal to whatever your number is when you set it equal to 0. Okay, on number 16, when we get the V shape, we get an absolute value, right? So all of these have the absolute value, so that doesn't narrow it down. But look, it opens down. So in order for it to open down, remember you have to have a negative in the front. So A and B both have a negative, so right away I know my answer can't be C or D. So now I just need to decide, is it have a plus 2 or a minus 2? Okay, so remember normally this is centered right here at the origin. This one moved up 2. So that tells me that this one is A. Okay, it did not go down 2. Okay, again, since this is something that is a graph, you can graph it on the calculator. Okay, you could go through and you could graph those equations on the calculator and determine which one of those actually looks like this graph. Okay, and if you want to find absolute value on the calculator, okay, you would go to Math and then go over to Num and then number 1 is your ABS. That stands for your absolute value. Okay, and again, if you had a question about where do I find absolute value on the calculator, that is something I can help you with while you're taking the test. So again, you can just graph those equations and see which one matches that graph. But if you just use your transformations with your absolute value, you can figure it out on your own. Okay, 17. The graph of the parabola, and then it gives you this equation, has this vertex, -2, -5. And again, you can see that right here from that number and that number. Remember, the sign changes when you pull it out. If this parabola is shifted 3 units up and 4 units to the right, what is the equation of the new parabola? Okay, well, 3 units up is going to change your value right there. So what does a -5 plus 3 give us? Because we're going to go up 3 units. Well, -5 plus 3, now we're at -2. And then this one says 4 units to the right. Okay, well, remember the plus 2, okay, it is going 2 units to the left. So if we're going from -2 and we're going 4 units to the right, we would add our 4 to our -2. So again, you just use the vertex here. So a -2 plus 4 is +2. Okay, but when we go to plug that in back into the equation, remember that positive becomes a minus sign in the equation. Right here becomes a minus sign in the equation. So let's write the new equation with those 2 values. So again, this is where your vertex would be at 2. -2 is your new vertex. So if you think about using that same equation, we have the 4 in the front. The x, because it's a +2, we're going to put -2 squared -2. So again, that 2, when you go to plug it back in here, changes to the opposite sign. This one stays the same. So there is your new equation. Okay, you can graph both the original equation, so you could graph this first original equation and your answer, and then just check. Did it go 3 units up and 4 units to the right as far as your vertex? You can check it on the graphing calculator. Okay, number 18. What are the solutions of x to the third minus 125? And again, this is another one of those that we've been using. So here's one of those that you need to have the formula memorized. This is our difference of cubes. Okay, so let's just write it down here. It's a cubed minus b cubed. And when you get something with cubes, then you do a minus b times your a squared plus ab plus b squared. So again, the only time we see the minus is in the first equation. Right here is where we see the minus sign. All the rest of the signs are plus. Okay, so that negative does not go with the a and the b when you go to plug it in. Okay, so right now I don't see a cube on my second number there. Okay, I have x to the cubed. So remember, if you're not sure what that number is, plug in the cube root on the calculator. Okay, and you'll get that this cube root is 5. So we can rewrite this as 5 cubed. Okay, so now we're going to go through and we're going to plug our x in everywhere there's an a, and we're going to plug our 5 in everywhere there's a b. So this is going to be x minus 5, and again, that's our only minus sign. The rest are all plus. Then x squared plus 5x, and then 5 squared is 25, so plus 25. Okay, and this one asks for the solution, so we have to keep going through and solve. So I'm going to set that part equal to 0. So you move the 5 over and it becomes positive 5. Okay, remember for the second piece, we can only plug it into the quadratic formula. So I'm going to use 1 is A, B is 5, C is 25. And so we're plugging in the opposite of B, so the opposite of 5, plus minus square root of, and then we're going to do our 5 squared minus 4 times our 1 times our 25 all over 2 times our 1. And again, if you look at this, this is going to be 25 minus 4 times 25 is 100. So 25 minus 100 is going to give me a negative. So I don't want to plug it in all at once. So I'm just going to simplify each part. Opposite of 5 is just negative 5. We said that would be 25 minus 100, which is going to give us a negative 75 divided by 2. Well, we're going to have to pull out I. So we're going to have negative 5 plus minus, pull out your I. When I do the square root of 75 on your Casio calculator, that's going to give you 5 rad 3. So remember the 5 goes in front of the I and the rad 3 after it, divided by 2. Well, that cannot simplify, but I not only have that answer, I have this one that I found previously, so I'm just going to put 5 in front of that, and then those are my solutions. 5 and then that fraction. Okay, so for that one, we need the difference of cubes formula and we need the quadratic formula in order to solve and find those solutions. Okay, you can check your solutions by plugging them back into the original equation. So like I could plug 5 back in there, see if it works. I can plug this in there for the x and see if it works. Okay, on 19, what value of k will make the left side of the equation a perfect square trinomial? Okay, so if we want a perfect square trinomial, we want to be able to factor this part and have that perfect square in the middle. Okay, so remember, to get the perfect square trinomial, this is usually what we have. And we have plus 2 and then whatever your AB is times x, and then plus your C, right? So whatever your A and B are, you're gonna multiply those together, actually. Okay, so we're gonna go through and see if we can solve this to find what's missing there. Okay, so for that center there, we want 2 times your A times your B. Okay, so we have to think about what is, okay, so we're going to call this piece A and this piece B for a moment. And if we're going to multiply those together, okay, we want to take the square root of each of these things right here. So square root of 36 is 6, and we just want the positive one. And then square root of 16 is 4. So the k part in the middle should be 2ab. Okay, so if I plug in my 6 for a, my 4 for b, you're going to get 2 times 6 times 4. So 2 times 6 times 4 equals 48. That is the number that you would want to put right there in the middle. So that if you factored it, you could get the perfect square trinomial. Okay, so really the key to remember is you're going to take the square root of this first number, square root of the last number, and then just multiply those together times 2. And then you'll have the perfect square trinomial. Okay, last one on number 20. Okay, they give you this part that you are dividing into, and they're telling you already what you're going to divide by using synthetic division. Okay, so we are not going to change the sign because there is no x minus or plus a number. It just gives you the number. So we're going to use the 3. Okay, if I look at my numbers here, I'm not missing any of the x values or the constant, so I don't need to put any zeros. So I got 2, 13, 24, and 9. And then we're just going to go through and do synthetic division. So bring the 2 straight down. 3 times 2 gives you 6. So then we add those two together. 13 plus 6 is 19. 3 times 19. If you multiply that on the calculator, we get 57. And we add that to our 24. That adds up to 81. And then 3 times 81 gives me 243. If I add that to 9, I get 252. Okay, and now it wants me to write it using the remainder theorem. So this is like we've done before. We're just going to go back and put our x's in, and then we have to make the remainder with the fraction. So since my highest exponent was 3, when I go to write my x's back in, this is going to be 2x squared plus 19x plus 81. And then your remainder is going to be the 252 over my x minus 3, but they actually just want the remainder as the answer. So they're saying if you plugged in your a, which is 3, in here, then we're getting 252. Okay, so they actually just want the remainder. Okay, so you're just going to take whatever you have left over there and type that answer in. Okay, remember the shortcut for doing this, if you don't like synthetic division, is you could take your original equation. So I'll show this in a different color. You could take your original equation and we could simply plug in, because again, it's not going to ask you to show your work. You're just trying to find the correct answer. You could go through and you could just plug in 3 everywhere there's an x. Okay, and you can try this on your calculator. Okay, if I plug that into the calculator just like that, I also get the 252. And again, that's what they're going to want you to type in as your answer is 252 for that one. Of course, you're going to have a different equation, so you're going to have a different remainder, but you can just substitute that number into the equation and see that will be the remainder. It's the same thing as if you do the synthetic division. Okay, so that finishes up this review. So study these so you can do well on the district post test.